All right, for the next problems, we're going to be focusing on how to work them with multiplication and division. And the work isn't really much different. There's just a little bit more factoring involved. So each one of these, if I have a factors up here and down there, they can still cancel out even though they're on different fractions, because when you multiply two fractions together, they're just basically the numerators times together and the denominators times together. So think of it as just one big fraction, and you can kind of go from there. So with the top left one, that's going to be a trinomial, but again, I don't like that x squared being negative, so I'll go ahead and take out a -1 there. And what that does is basically change the sign of everything. And I'm going to put the x squared first because, I want the x squared in standard. I want it in standard form. So I'm going to put the x squared at the beginning. So that's negative x squared, negative x if I distribute that -1, and positive 6. So that's a little bit more user friendly. X minus 5 does not factor at all. So we'll keep that as it is. 2x squared minus 50. 2 and 50 can 2 can be taken out of that, so that's a GCF. And I can actually break that down even further. So that's going to be 2x plus 5 and x minus 5, because that is a difference of 2 squares. So I can do that as a plus and a minus the square roots. 4x squared plus 16x plus 12, looks like 4 can go into all three of those terms. So if I divide those by 4, I get x squared plus 4x plus 3. And I can break that down even further. So that's going to give me 4. And that should be x plus 3, x plus 1. So if I'm going to rewrite this, it's going to look like -1. And I forgot I can break this down even further. This is x squared plus x minus 6. Now it looks like that's going to be -1 x plus 3 and x minus 2. And you can check that if you were to FOIL them back out. That's x squared minus 2x plus 3x, which is going to give you x, and then minus 6. So I think we got all our factors now. So it's going to be -1 x plus 3, x minus 2. That's your top left in factored form. X minus 5, the bottom left is going to stay x minus 5. And I'm just going to write this as one fraction. So this is going to be 2x plus 5, x minus 5. So I'm just going to say times. And this bottom right one will be 4x plus 3, x plus 1. So again, times 4, x plus 3, x plus 1. All right, from there, I look for anything I can cancel out. As long as I have a pair, a one matching pair on the top and bottom, those can cancel out. So I can get rid of those x plus 3s. I also have an x minus 5 here and an x minus 5 here. So I'm going to get rid of those as well. Looks like I have all my factors left over. X minus 2, x plus 5, and x plus 1 don't have anything I can cross out. I do see a 2 and a 4. So anytime you have numbers by themselves outside of the factors, they can reduce. So we know that 2 over 4, that's going to reduce to 1/2. So I am going to write that as 1 over 2. So that -1 times 1, that's just going to be a -1 on the top. So my final form for this should be -1 x minus 2, x plus 5 over 2 and x plus 1. And the 1 doesn't need to really be there, so you can kind of erase that, but it's going to be you still have to have the negative sign. So negative x minus 2, x plus 5 over 2, x plus 1. So kind of the final way to write that, the most simplified way would be just like that. Now I want to go back and get our restrictions and state our domain. We don't have to do the domain on these ones just because it's a lot of restrictions to think about and write out, but we still have to get our restrictions. So remember, our restrictions don't come from what I crossed out. They come from all the factors that make the denominator equal to 0. So the restrictions in this case would be positive 5, since 5 minus 5 is 0. So x cannot equal 5. X cannot equal negative 3, because negative 3 plus 3 is 0. And x cannot equal negative 1. So there's going to be 3 restrictions. Your domain would be all real numbers except 5, negative 3, and negative 1. And you can write that out in interval notation. I'll do that for you so you can see. It's going to be negative infinity to negative 3. That's my smallest number. U, negative 3 to negative 1. That's my next one. U, negative 1 to 5. And U, 5 to infinity. So they can get kind of wide when you write your domain out. Anytime you have anything more than 2 restrictions, really, it's a wide domain to write. So I tend to not write that out all the time, but at least get your restrictions so you know what you can't plug into this. Okay, this problem is a division problem, and we don't really treat these much differently. The only thing that we want to fix first before we even do anything is make it a multiplication problem, and we can do that by multiplying this second fraction by the reciprocal. So I'm going to keep, you might have heard the phrase keep, change, flip. So we're going to keep this fraction the way it is. We're going to change this one to multiplication. And we're going to flip the second fraction and write its reciprocal. So I'm going to do that first. So that's going to be 2 minus x over 2x squared plus 4x plus 2. We're going to keep that one. We're going to change this to times. And we're going to flip this to 2x cubed minus 2x over x squared plus 3x minus 10. So right off the bat, by doing that, basically it's just like the last problem we did. We're going to factor both the tops and bottoms of both of these fractions and kind of put them all together as one. So this is backwards, so I'm going to factor out a negative 1, and we'll say x minus 2. This has a GCF of 2x. So that's going to give me x squared minus 1. And x squared minus 1 can further factor to x plus 1, x minus 1. So that's going to be 2x, x plus 1, x minus 1. This has a GCF as well of 2. And x squared plus 2x plus 1 is a trinomial. It's going to be x plus 1, x plus 1. So 2x plus 1, x plus 1. And this is a trinomial, and negative 10 can break down to, let me think, 5 and 2, and I can get positive 3 from if 5 is positive and 2 is negative. So it's going to be x plus 5 and x minus 2. So let me rewrite this. Before we finish up canceling this problem, I want to make a note. Restrictions for division problems are a little bit different. Because we're dividing by this fraction, regardless if you talk about the denominator here or the original denominator, both of those cannot be 0 because you can't divide by 0. So you can't divide by the 0 here or there. So restrictions are going to apply to both of these as well as that section there, okay? So whatever makes this, and this 0 in a division problem only are considered your restrictions. So I want to talk about that first before we sit there and cancel out and forget about them. So my restrictions in this case is going to be x cannot equal -1 and -1 again, so just -1 once. X cannot equal -5. X cannot equal 2. But if you go up here, x can also not equal up here 1. 1's going to make that 0. And also you have a 2x hanging out. And if 0 is the value in there, then that's going to make that 0. So anytime x is by itself or just with a number but not inside of parentheses, that's going to be 0. So we have a lot of restrictions. I'm not going to write the domain out for that, but those are your restrictions. Let's go ahead and circle those. And just remember, restrictions are applying to this part, this part, this part when it starts as a division problem. Only division though. If it's multiplication, it's just going to be these two. So let's go back and cancel some things out from the denominator. This one has an x minus 2. So we'll cancel that out. It has an x plus 1. And I have another x plus 1, but we only can cancel out one pair. So one of them is going to be left over. I don't have an x minus 1. I do have a 2, but not an x. So just the 2 there. So I'm going to have a leftover -1x, which is just -x. -x. And then I have an x minus 1. All right, on the bottom I have x plus 1, x plus 5. And it looks like that's it. All right, example number 6 is a division problem as well. Think about this fraction bar as just the division sign. So if we rewrite it, it's going to be 2x minus 6 over x minus 1 divided by x minus 3 over x squared minus 1. Which is basically like the last problem we did. So this would be a good opportunity for you to pause the video and see if you can try this one on your own. And I'll have it worked it out. So pause the video, try it on your own. Unpause it, and I'll have the solution available for you to check. Okay, hopefully you've got a chance to check the solution. Let me just kind of walk you through what I have. So I did kept that fraction the same. I changed that to times. I flipped this one. The factoring is a little bit less involved on this problem. This just has a GCF, so that's going to be 2, x minus 3. This is a difference of 2 squares, x plus 1, x minus 1. And the bottom two don't factor at all. The restrictions on these are going to be what make the denominator 0. So 1 and 3 are not allowed. But also, if you look at the top here, because this came from a division problem, you can also say x cannot equal -1 because -1 makes that 0. And we don't want to divide by that because that's under the division sign here. So those are your 3 restrictions. If you put your factors together, you can see the x minus 1s cancel out and the x minus 3s cancel out. And so you're only left with stuff on the numerator, 2 and x plus 1. When there's nothing on the other side, you can put a 1. If it's a fraction where 1's underneath, then just get rid of it. So it's going to be 2 parentheses x plus 1. All right, last example for the notes, number 7. It's got 3 parts to it. You're dividing and then timesing. So this is division. This is the only one we're going to flip. This one's going to stay put. So is the first one. So I'm going to change that to times, and I'm going to flip this. So let me rewrite that first. Oops, I already messed up there. So 3x squared minus 6x minus 72 over 2 minus x. All right, so we got all that written out correctly. Let's go ahead and factor. These factors shouldn't be too difficult. So let's see, we got x squared minus 4, that's x plus 2, x minus 2. This is going to be a GCF, so x parentheses x minus 6. This is a negative 1 factor, so negative 1, x minus 2. This is, see, 3, 6, and 72, I can GCF that, so 3x squared minus 2x minus 72 divided by 3 should be 24. And I can further break that down. Two numbers that can multiply to negative 24 and add to negative 2, that's going to be negative 6 and positive 4. So that's going to be 3x minus 6, x plus 4. This is a GCF. I can take out a 2x. So that's going to be 2x, x plus 1. I can take out a 5 for all of these. So that's going to be 5x squared plus 2x minus 8. And again, I can break that down. That's a trinomial. So that's going to be x, let's see, 8, negative 8, x plus 4, and x minus 2 should work on that. So got all those factored. Let me clean it up and rewrite it. I'm just going to make one big fraction bar. So I try to separate what the original fractions were with multiplication so you can see them. The reason I did that was because we want to make sure that when we're doing restrictions, since this fraction came after the division, we want to make sure that what was on the top and bottom that makes that 0 is considered a restriction. So let's get those first before I cross them out and forget about them. So if it's x by itself, that's going to be 0. X cannot equal 0. The opposite of x minus 6 is 6. Negative 1 is not going to play into that, but 2 minus 2 is a restriction. Let's pop up to the top. So I can't use 6 here or negative 4. So we can say negative 4. We're not going to use this top because, again, that was multiplication. So back to the denominator here. This is negative 4. We already got that. And 2, we already got that. So these are your 4 restrictions. Now let's look for things to cancel out. Let's see, I have a x minus 2 here, x plus 2. I don't have an x plus 2 on the bottom. So x minus 2, let's get rid of that one. I have an x minus 6 there and there. Those are gone. Let's see, I have an x plus 4. No x plus 1. No x plus minus 2. I have a 3 times 2x and an x. Oh, I have an x on the outsides here. So those x can cancel out. And so let's see what I have left. I have a x plus 2, a 3, a 2, and an x plus 1. So let me rewrite that. And 3 times 2, that's going to be 6. So I'm going to put that out here. 3 times 2 is 6. And then I have an x plus 1. The denominator has a -1, a 5, and an x minus 2. So that's -1 times 5, -5, and x minus 2. And that's okay to write. We tend to not want to put negatives on the denominator. So if you have one negative hanging out, best place to put it is right on the outside. Second best place to put it would be up at the top number there, but that's kind of what you want to do on that problem. Well, that takes care of all the examples for this lesson. Hopefully this was helpful, and you can go back and review the day 1 assignment. Again, if you have any questions, let me know.